Hi, good evening. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss the problems on Stoke's theorem. So, the Stoke's theorem already we have seen in the previous video. It is a transformation between the line integral and the surface integral. So the statement is, let S be an open surface bounded by a closed non-intersecting curve. If f bar is any vector differentiable function, then integral f bar dot dr bar over the closed curve C is equal to integral over S curl f bar dot n cap into ds, where C is traversed in the positive direction, or we call it as anti-clockwise direction, and n bar is the unit outward drawn normal vector at any point on the surface S. So already we have seen the theorem. Just we are applying the theorem for problems, for verification problems and for finding the line integral or surface integral. So now see the problem number 1. Verify Stoke's theorem for the function f bar is equal to x square I bar plus xy j bar integrated around the square in the plane z is equal to 0, whose sides are along the lines x is equal to 0, y is equal to 0, x is equal to 0 means it is y axis, and y is equal to 0 means x axis. This is x is equal to a, and this is y is equal to a. So the line integral is to be evaluated along the line y is equal to 0, x is equal to a, y is equal to a, and x is equal to a, the line integral or integral f bar dot dr bar. Given f bar is x square I bar plus xy j bar. So by Stoke's theorem, what we have to verify is integral over the closed curve C, integral over the closed curve C f bar dot dr bar is equal to integral over the surface f curl f bar dot n bar into ds, where n bar is the unit outward normal vector to the surface, right? So to verify this theorem, we need certain terms, that is curl f bar we need, then f bar dot dr bar. So before going to that, I want to calculate curl f bar. What is curl f bar? Del cross f bar. Del is a vector point function. And del cross f bar, it is can be calculated by considering the determinant I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. The first row, last row x square, xy, and last term 0. So when you expand this I bar into dou by dou x of 0, I bar, and discarding this column and this row, dou by dou y of 0, 0 minus dou by dou z of xy, that is also 0, minus j bar into dou by dou x of 0, 0, dou by dou z of x square, that is also 0, plus k bar into dou by dou x of xy, k bar into dou by dou x of xy, that is y, minus dou by dou y of x square, that is equal to 0. So the value is equal to y into k bar. Y into k bar. So that is already here we have calculated. Now consider curl f bar dot n bar into ds. That is integral over s. Curl f bar already we have calculated y into k bar dot n bar into ds. But what we know that if you consider the projection of the given region in xy plane, then ds is equal to dx into dy by magnitude of n bar dot k bar. Or from this what I can write, n bar dot k bar ds is equal to dx into dy. So this is a small formula like, so here it is n bar dot k bar into ds, that can be replaced by dx dy, y as it is. So integral y dx dy. What is dx dy? It is a area of the square where the boundaries are x0, x is equal to a, y0 and y is equal to a. So to evaluate this integral, we have to consider the strip inside the region. Then y varies from 0 to a one limit and x varies from 0 to a is the other limit. Because all the limits are constant limits, you can perform the integration according to your interest. So there is no restriction at all. On integrating integral 0 to a, y integration y square by 2, 0 to a dx. Or on substituting the limits, upper limit a square by 2, lower limit 0, integral 0 to a dx. That is a square by 2 constant, integral 0 to a 1 dx. Or you can write it as integral dx is x between 0 and a. That is a square by 2 into a, that is equal to a cube by 2. So that is the integral over c f bar dot dr bar, the left hand side part calculated, and that value as shown as a cube by 2. Now to verify the theorem, Stokes theorem, we need to consider the right hand side part also. That is integral, this is calculated as integral curl f bar dot n cap ds. Already we have calculated the right hand side or LHS, that I will see in the slide. We have calculated the right hand side part. This is the right hand side part. Now we are going to consider the left hand side in the next case. So what is RHS is here? RHS is integral curl f bar dot n cap into ds. That is already calculated. It is a cube by t. A cube by 2. Now I am considering LHS. What is LHS? Integral over the closed curve C f bar dot dr bar. That means what it is, along with here I have drawn one already. This is x-axis and this is y-axis, and this is 0 comma 0. This is a comma 0. This is the line x is equal to a. This is x0 and y is equal to 0 and y is equal to a. Now, we have to evaluate the line integral along this closed curve. What is the closed curve? In this direction, OA. Then we have to go for AB. Then we have to go for BC. BC means this is 0 comma A. Then we have to go for CO. So, in this direction, we have to evaluate. That is, I am writing it is integral f bar dot dr bar along OA plus integral f bar dot dr bar along AB plus integral f bar dot dr bar along BC plus integral f bar dot dr bar along CO. So in all the directions we have to calculate. That is, the direction will be like this. So then it will be a closed curve. The direction will be the anti-clockwise direction, which we call it as a positive direction. So here I have given all the values for the above integrals. How these values will obtain, we see here. We see how the values. First integral along OA f bar dot dr bar. What is f bar dot dr bar? Now I will see what is f bar dot dr bar. Already we have calculated f bar dot dr bar. No. So f bar dot dr bar. What is f bar? Integral along O. F bar I will see here. X square I bar plus xyj bar, the dot product with dxi bar plus dyj bar. This is equal to integral along OA x square dx plus xy dy. But along OA, this is f bar dot dr bar. This will keep in mind. In every integral, we can substitute this only. So along OA, what is along OA? What is the equation of OA? X-axis, y is equal to 0. So dy also 0. And x varies from here 0 to a. X varies from 0 to a. Y0 means dy 0. Second term, entire term 0. Only you'll get x square dx value. Second term is 0. dy 0, y 0, entire term 0. First term x square dx, but x varies from 0 to a. That is x cube by 3 between 0 and a. X square integration x cube by 3. So on substituting the upper limit a cube by 3 minus 0, that is equal to a cube by 3. That is the first value, a cube by 3. So now you are maybe clear how to get the value of integral f bar dot dr bar along OA bar. Similarly, we calculate along, what is along? AB. Along AB. What is the equation of AB? Along AB means in this direction. So the equation of AB is x is equal to A. So now I will write along AB. The equation is along AB. Here AB equation x0, x is equal to A, sorry. Then dx is constant, that is 0. X constant means dx constant derivative, that is 0. But y is a variable, it varies from 0 to A. Y varies from 0 to A. This is y0. A fixed here and here, but this value 0, this value A, 0 to A. This value A, and this is 0. 0 to A, y is a variable. So the function x square dx plus xy dy. X square dx plus xy dy. Already we have calculated. Along AB is equal to. So dx0, that means first term 0. dx0 already, because x is equal to A. dx0. So xa, y, dy as it is, and y is equal to 0 to A. I hope this is clear. dx0 means first term entire term 0. Second term dy remains same, y same, x is equal to A and replacing ay dy, or a into y dy integration y square by 2 between 0 and A. That is a by 2 into a square, that is a cube by 2. A cube by 2. That is the second integration. A cube by 2. That is the second value. The line integral along AB. Similarly, here I will calculate along BC also. Along BC means in this direction. Along BC means what? What is the BC equation? Y is equal to A. That means what? Dy will be 0. Because y is constant, dy will be 0. But x is a variable factor here. X varies from A to 0. X, here it is A and it goes to 0. So A to 0 x limit. So integral along BC f bar dot dr bar is equal to integral x square dx plus xy dy. The limits x is A to 0. But dy 0 means second term entire term 0. This is 0. So integral x square dx between A and 0. So what is the integration? X square integration x cube by 3 between A and 0. So upper limit. What is the upper limit? X square dx along BC in this direction. The value is 0 minus A cube by 3. So this will get minus A cube by 3. Minus A cube by 3. Third one is minus A cube by 3. So this you have to put minus symbol. That is the third one. Minus A cube by 3. So the last remaining limit is we have to find along CO. Along CO means x0 dx0. First term will be 0. So I will calculate here that also. So last along CO. So what is the equation of CO? Because it is y-axis x0 is the equation. So dx is equal to 0. But y is a variable factor. Y varies from A to 0. Y varies from A to 0. Therefore, integral f bar dot dr bar along CO is integral along CO x square dx plus xy dy. Because dx 0, the entire term will be 0. The only first term will be the value x into x also 0, right? So x also 0. The second term, first term, both are zeros. So 0, that is equal to 0. This is the fourth limit. Already you can observe that the fourth integral value 0. The first integral value calculated a cube by 3, that is here. The second integral value calculated here, that is a cube by 2. A cube by 2. Third value minus a cube by 3, that also we mentioned here. Last integral value 0. So this and this will get cancelled. A cube by 3, a cube by 3, plus and minus. The value is a cube minus 2. So therefore, the line integral, integral along the closed curve C f bar dot dr bar is equal to a cube by 3 plus a square by 2 minus a cube by 3 plus 0, and these two values are 0, cancel plus and minus, you'll get a cube by t, that is called equation number 2. But what is a cube by 2 here? This is the first value, integral over s curl f bar dot n cap into ds. That value is also a cube by 2. And integral f bar dot dr bar also a cube by 2. Therefore, from 1 and 2 equations, the theorem, Stokes theorem verified. The Stokes theorem verified. So in this way, you can verify. You have to evaluate the line integral. You know how to evaluate the line integral along the given region, closed curve. Similarly, you can evaluate the double integral or surface integral. Surface integral, double integral limits have been same on considering the projection. But the only variation is there it is curl f bar dot n cap ds, there it is dx dy only. So in this way you can show that the values on the left hand side and right hand side are same. So hence the Stokes theorem is verified. So in this connection I will give one more example to you also. This is also using Stokes theorem. So using Stokes theorem, see the problem number 2. Using Stokes theorem, evaluate integral over the closed curve C f bar dot dr bar, where f bar is given as a vector and C is the boundary of the triangle whose vertices are 0, 0, 0, 1, 0, 0 and 1, 1, 0. That means what? All z values are 0. That means the function is defined in xy plane only. This is xy plane. So 1, 0, 0, 0. There is no z axis. Because all values are z, all the function is defined in xy plane only. And 1, 0, 0 means this is the point on x-axis only. 1, 1, 0. What is 1, 1, 0? x1, y1. So where it is? 1, 1, 0. Where it is x1, y1. x1, y1. This is 1 and this you can write it as 1, 1, 0. Now this will be like this. So this is a triangle already given that. So this is the curve given. What is the curve is C. C is the curve. It is O, this is A, this is B. Clearly it is a triangle. Clearly because you can eliminate the last two values for z values because all are zeros, you need not to consider. So already given that, so I also mentioned 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, right? Now we have to evaluate this one, integral over the closed curve C f bar dot dr bar. But what he is saying that use Stokes theorem to evaluate this. That means this is equivalent to by Stokes theorem. What is by Stokes theorem? We know the statement. By Stokes theorem, you have integral f bar dot dr bar over the closed curve C is equal to double integral curl f bar dot n cap into ds over the surface S. Am I right? So to evaluate this value, I am using Stokes theorem means you should not calculate integral f bar dot dr bar in this example. You have to calculate this and you have to find the result. So before going to that, we calculate curl f bar. What is curl f bar means? Del cross f bar, that is I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, and f bar coefficient, I bar coefficient. In f bar, I bar coefficient x plus y, j bar coefficient 2x minus z, k bar coefficient y plus z. That is I bar into dou by dou y of this one, that is 1, minus dou by dou z of this one, dou by dou z of 2x 0 and this is minus 1, so this is plus 1, minus dou by dou z of this one, I bar into this minus this, so 1 plus 1 plus j bar into, minus j bar into, what we will get? Minus j bar into dou by dou x of this one 0, dou by dou z of this one, j bar also 0, plus k bar into dou by dou x of this one 2 minus 1. So what you have obtained it is equal to 2I bar plus K bar. 2I bar plus K bar is the curl F bar. But here, the outward normal vector for this surface, the outward normal vector is, because it is defined in xy plane, the outward normal vector will be in the direction of positive z-axis. So, K n bar, the outward normal vector. So, I will shown here, the outward normal vector n bar here, I will write here, n cap is equal to I bar. This is outward normal vector is K bar. Because the outward normal vector for this surface is in the direction of positive z-axis. So, n bar is equal to K bar and curl F bar dot n cap is equal to 2I bar plus K bar dot K bar, that is equal to 1. 2I bar dot K bar, I bar dot K bar 0, K bar dot K bar 1, that is equal to 1. So, now what will be integral? Therefore, integral over S curl F bar dot n cap ds is equal to, what is curl F bar? What is curl F bar? 2I bar plus K bar. Already that value also calculated 1 into, this entire value is 1. Because it is defined in xy plane, the projection will be dx into dy by magnitude of n cap dot K bar. Or I can write the same thing as ds n bar dot K bar. So, n bar dot K bar, this value, entire value integral ds. So, this is equal to, I will show that, n bar dot K bar. N bar dot K bar is equal to, what is? 2I bar plus K bar. ds value dx into dy. I will write here. ds is equal to dx into dy by n cap dot K bar. So, ds into n bar dot K bar is equal to dx into dy. So, n bar dot K bar, what is the value? Here I will see the value. Curl F bar dot n cap, already we have calculated. Curl F bar dot n cap is equal to 1 into n bar dot K bar also 1. So, this is double integral dx into dy. N bar dot K bar also 1. So, this is dx into dy. So, dx into dy means what is? This is the area of this triangle. Area of this triangle is half into base into height. Am I right? What is the triangle area? Base into height. This is 1 unit and this is also 1 unit. So, what you will get here, I will show. So, this is dx into dy. This is the area of the triangle OAB. Double integral dx dy over the area means it is triangle area, that is half into. So, length is 1 unit and that means base, and height also 1 unit, that is equal to 1 by 2, which is the required value by using the Stokes theorem. Required value by Stokes theorem. Clearly, half into, this is 1 unit and this is also 1 unit because the length is 1. Here this is 1, this is 1, this is 0, this is 1, means it is 1 unit. So, half into base into height is the triangle area. Or you can consider the strip also. If you consider the strip, this is y is equal to 0 to y is equal to x. And x varies from 0 to 1. That also you can do that, but it is not required. If you want to do that integral dy into dx, 0 to x, y, 0 to x, x 0 to, what is the value? 1 I think, y 0 to 1. So, on doing integration, integral 0 to 1, integral dy is y 0 to x of dx. That is integral 0 to 1, y means x minus 0, x dx. Or x square by 2 between 0 and 1, that is equal to 1 by 2. Both are same. You can find the area directly by the formula half into triangle area, base into height. So, in that way you can calculate the triangle area. These two are the required solution. So, this is done by using the Stokes theorem. So, this is also can be considered as the application problem of Stokes theorem. right? So these all problems we have taken from the mathematical methods by Chand publishers of year 2006, and this is also mentioned in the slide one itself also, vector integration problems on Stokes theorem, and by one, this one is the reference of the problem taken from the book is this is mathematical methods book. So please note that if you want any queries, you can verify the book also. So with the few words, I conclude my lecture of today's. It is thank you, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.